students, we will continue that chapter force and pressure, and this is lecture 4. Here we will discuss fluid pressure and atmospheric pressure. Okay, so the pressure that is due to the fluid, it can be water, it can be, just a minute, it can be water, it can be mercury or any other fluid, and we'll discuss the atmospheric pressure that is present inside the balloon that you have blown, and also we'll discuss if we are traveling or if we are going for trekking, at that time at the top of the hill, what will be the atmospheric pressure and why we should carry the oxygen cylinder when they are going to the trekking, going for trekking in the Mount Everest or very highest mountains. So all those things, it will be clear here after this lecture. Now the conditions for the consideration of fluid pressure. Here we will consider two conditions. Two conditions we'll consider. We'll consider two conditions. One is the open condition or open channel flow. And the next one, that is the closed condition or closed condition. So the fluid pressure, those conditions, whatever given above, these are the static fluid pressure or hydrostatic pressure. Now let me discuss this term. This is very important term. Very important term, static fluid pressure. And I know that till now you don't know what is the difference between only the fluid pressure and static fluid pressure. We are considering for the static fluid pressure, it does not depend on the structure of the container. Structure of the container, right? It is square or it is round shaped or it is any other shape, suppose this type of shape. So it does not depend on the shape and it does not depend on the surface area. So static fluid pressure only depends on the water level depth. That means, suppose I have a container here, I have water here. So what will be the depth? This much. So this depth we will consider here. So the pressure here considered based on the what? Based on the depth of the fluid. Because the pressure produced due to the fluid movement can be considered negligible. Another pressure variation we have in the flowing, flowing fluid or movement, fluid movement. But here you know that we are considering the depth of the fluid. We are not considering whatever the pressure produced due to the fluid movement. And the static fluid pressure does not depend on what? Surface area, the shape of the fluid container, and the total volume and mass of the liquid. Okay? Here, the pressure in the fluids. Fine. Very good example here. One container here you have and some holes for jets you have. Now, one thing you can notice in your life, that if you see the overhead tank of your house or your apartment, you can see that the overhead tank, that is a big one. The overhead tank, that is a big one. And you can see the holes for the jets or the pipelines that is coming from the bottom of the tank, from the very near to the bottom of the tank, right? So here, why they are doing all these things, or why we will do this thing? Because this is filled with the water, right? And this depth is very important. Just a minute, I am just changing the pointer here. So this depth is very important. This depth is very important. And here you have the pipeline. Okay. from where the water will flow, and it will go to your home, every home, or it will go to your kitchen or every room. Okay, so the pressure exerted by the fluid in this container is transmitted undiminished in all direction on the walls of the container. So fine, this is a very good container where water has been filled. Here you can see that. Now you see one thing, this is the top of the water level, and this is the strongest jet, and the depth of this jet is the highest, whereas the second one, the depth is smaller, and this one is the smallest depth, right? So here you can see that this is the weakest jet and this one is the strongest jet, and this is only for the pressure of the fluid. Now the fluid is our fluid that we have taken as an example, that is water. That is water. Now fluid here you can see that is water, and the pressure that in this fluid that depends on the depth of the fluid also. Now here, why this is the strongest jet and this is the weakest jet? The simple reason is that here you can see that the height of the water level that is very high here, and here you have the depth is very small, and here you have the smallest one. So the pressure, the pressure in this fluid or in this water, the pressure is highest for this last, the bottom jet. So here the strongest jet you have. So here these poles, it will feel the stronger pressure. So that's why you can see that this is the strongest jet. Now it is clear, or I will repeat this one. So always you think that we are using this example in our daily life, that we are using in our overhead tank. In our overhead tank. In another way also I can discuss this thing. If the water quantity is very small amount, that means water level, it becomes at this point. You can see that the pressure of the water in your tap, basin tap, that is less. Okay, that becomes weaker. And because this depth of the water level, that is less. So pressure in fluids, that depends on whatever the depth you have and where you are putting your pipeline. Okay. Now the factors affect the fluid pressure. There are two factors that affect the fluid pressure. One is the depth of fluid and another is the density. Fine. Now depth of fluid. If the depth increases, the pressure exerted by the fluid becomes more. That's why if the overhead tank is filled, you can see that the pipeline is here. The pipeline is here. The pipeline is from this position, right? So you can see that at that time, the speed of the water or the pressure of the water in your tap, that is very high. But if the water level becomes small, at that time you can see that you are getting low pressure water. So here, that means the depth increases, at that time pressure exerted by the fluid becomes more. If the depth increases, and depth means this one. Okay, from this surface to this point, this depth. If it is increases, so depth, if it is increases, pressure, what it will do? It will also increase, right? Clear about the depth point? Now, here the density point. So we can put water as a fluid. We can put any other liquid or any other liquid we can put other than water, we can put oil, or we can put glycerin, we can put glycerin. So different things we can put, right? So denser fluids such as water exert more pressure than lighter fluids such as air. The molecules in the denser fluid are close to each other, resulting in more collisions in the given area. So this results in the exertion of more pressure. So density of the fluid, what is density? What is the effect of the density of the fluid? Denser fluid, that means which liquid you have less density, at that time you can see that the pressure is less. If you have denser fluid, you can see that at that time the pressure will be high. So why this happens? Because in the denser fluid, you can see that more collisions in the given area. So particularly suppose you have this area and light density, light density liquid, that means you have the atoms, you have these atoms very far away from each other, right? So the interaction is less, or the collision is less. So if collision is less, at that time it will result some less amount of pressure. But whenever you have denser medium, at that time you can see that in this container, suppose I have denser medium, here. You can see that the the molecules is very near. The molecules is very near. Suppose they are very near. So the possibility of collision, that increases. And due to this more collision, it will exert more pressure. So if you are using denser medium or denser liquid, then your pressure will be high. If you are using less, that means the density is less in your liquid, at that time you can see that the pressure is also less. Now the pressure exerted by the liquid gases, here we will prove. First one, you can see that suppose some rubber balloon has been added at the bottom of the container, right? So here the liquid, if I'm keeping the liquid here, now the height of the liquid is this much, or the depth of the liquid is this much, right? And it will exert some pressure on the balloon and it will blow, right? Now the height of the liquid for the second case, that is very high amount. At that time you can see that the rubber balloon, that blown very well, right? The size is very high. That means what? This will give more pressure than the first one. This will give more pressure than the first one. So the pressure, whatever you have, that depends on the height of the liquid inside the column. Height of the liquid inside the column. Good. Now liquid exerts sideways pressure also. Fine. So that we will prove. Sorry, that will prove from this picture and this picture. Now suppose one container you have here and you have liquid here. You can take water, liquid here, and in the side you have one column where some rubber balloon has been attached. So here you can see that if the rubber balloon you are attaching here if you have the water, at that time it will blow. So it will blow at that time, and you can see that the rubber balloon, it has some dimension here, right? That means it has been blown. So now that means what? The liquid exerts sideways pressure also. Another thing, you can see that this experiment we have done in our childhood. Yes or no? Yes, we have done in our childhood. We are taking in the in a plastic packet, we are just filling with water, and we are just keeping the mouth. And here some water, We are filling now with one alpine or septipine. Just we are making some holes here. Just we are making some holes here. You can see that the water will come out from this. The water will come out from this. So that thing also here you can see that they have done. So where there is a hole here, there is a hole here, there is a hole here, and you can see that that means the sideways you have some, in the side walls you have some holes. So the water that will give the pressure on the side walls, and you can see that for the same height it will exert the same pressure, because here you can see that how much strong the jet is, how much strong the jet here, both are same. So the liquids exert equal pressure at the same height. The liquid exerts sideways pressure, that has been proved by this point, this one. And the liquid exert pressure on the walls of the container. The liquid exert pressure on the bottom of a container. This has been explained using these two, and it depends upon the height of the liquid column. That also we have discussed. So always remember these points. These points are very, very important, that what will be the pressure exerted by the liquid gases. Now, how to calculate the fluid pressure? So there are three methods. There are three methods that can be used for the calculation of fluid pressure. One is that by calculating the fluid pressure. One is that by calculating the fluid pressure. Another is that by finding the density of the liquid. And the third one by considering the variables in the equation of fluid pressure, right? So how to calculate the fluid pressure? Fluid pressure that is dependent on the density and height of the fluid. Just now we have discussed that fluid pressure that depends on two factors. First factor, that is the depth, and second factor, that is the density. So, and it is independent of the mass of the fluid. So now we will calculate the fluid pressure using the fluid, calculating the fluid pressure, calculating the density of the liquid, and also some other variables that I will consider. Now, different questions that may come, and these questions we are specifying here. First question, this is the why do fluid exert pressure? Fine. Next question, you please try to answer yourself. What causes the fluid to flow? And what will increase gas pressure? How does temperature affect the gas pressure? So all these questions, all the answers already we have discussed in these slides. Now the upthrust, this is also the pressure due to the water or due to the liquid. So upward force exerted by a fluid on an object is known as upthrust or buoyant force So upward force exerted by the fluid on an object is known as upthrust or buoyant force. Now you can see that this upthrust we are using at the time of boat or ship. At that time we are using this one upthrust. That is very, very important point. And sorry, so we are using this upthrust phenomenon. Now the atmospheric pressure and gauge pressure. The atmospheric pressure at any point is measured as the weight of the column of the air of unit cross-sectional area extended from the point under consideration to the top of the atmosphere. Whatever written here, you will understand if you just try to memorize the pressure machine used by doctors, where liquid mercury we are using. Or another thing also we can do ourselves, that I will discuss in the next slide. So here, this principle that has been invented or introduced by Italian scientist Evangelista Torricelli. So Torricelli's column now we will see. Now mercury barometer. We have just taking the mercury barometer here. Now here you can see that, just a minute. Now here you can see that there is a column which is made up of glass, and this is a glass container, and here you can see that liquid, in the liquid form we have the mercury. Now this is vacuum, where you have the mercury vapors whose pressure is very negligible, so we are calling this portion is vacuum. Now the atmosphere, it will exert the force on the surface of this container, the water, the mercury, liquid mercury of the container. And due to this atmospheric pressure, this liquid will move inside this column, and it will fill the column. So whatever the height of the column, that depends on the atmospheric pressure. That depends on the atmospheric pressure. If the atmospheric pressure is very high, you can see that the height of this mercury inside the column, that will be very high. So here, this is the mercury barometer that we are using this phenomena. So now here the pressure inside the column must be equal to the atmospheric pressure. Now what is the atmospheric pressure? That is the rho GH, where rho, that is the density of the fluid, that is the density of the fluid, and PA, that is the atmospheric pressure, that is the atmospheric pressure, and G, that is the acceleration due to gravity, okay. So here we are, pressure inside the column must be equal to the atmospheric pressure, and the atmospheric pressure PA, that is the rho into G into H. H is the height of this height, and here rho GH. H is the height of the mercury column, and height means this height. Okay. Now generally this height equals to 76 centimeter, and commonly it is said that the pressure in terms of centimeter or millimeter of the mercury. So here the pressure, that is the 76 centimeter in terms of the mercury. Now the manometer. So here this instrument, this is an open tube manometer has been shown here. This point is open and this is enclosed. Now here two types of liquid we are adding. Here this is useful for measuring the pressure difference. And in this apparatus, this has been shown here. Now this is the atmospheric pressure which is applicable to this point. And here we have P and Q. And this one is the column A and this one is column B. And this column B, that is filled with one type of liquid, and this column A, that is filled with another type of liquid, right? So the pressure P1, that is greater than atmospheric pressure. Now we'll discuss elaborately. This is a U-shaped apparatus where you can see that we can find out the pressure difference between oil or water, or we can find out the pressure difference between the high density liquid and low density liquid. So this apparatus consists of U-tube. Here you have the U-tube, not that U-tube, okay, that you are searching always. This is another U-tube, that is U-shaped tube. So containing a suitable liquid such as oil for measuring small pressure difference and high density liquid for measuring large pressure differences. right? And at one end, the tube is open where atmospheric pressure is acting on, and it is connected to the system whose pressure is to be measured. This is the system whose pressure is to be measured. Now, here you can see that the 2 points P and Q. P and Q. Okay. This point you can see the pressure P is equal to the pressure Q. Both the liquids are at the same level because at the point P, this is the level, at the point Q, this is the level. So the pressure P is equal to the pressure Q, and we measure usually the gauge pressure, which is equal to P minus of PA. Okay, where PA is the atmospheric pressure. Atmospheric pressure. And the atmospheric pressure already we have measured rho GH. We can measure using this equation. So here you can see that the pressure whatever at this level, that equal to the pressure at this level. Now the atmospheric pressure, the gaseous pressure, this we are discussing. So gases exert same pressure on the walls of the container in all directions. So here you know that for the liquid, suppose for the liquid, the atom, the molecules, they are very close, right? But for the air, the molecules are at a distant point. The molecules are at distant point, okay, in the air. But that means this interatomic distance is very high in case of air, but it is very low in case of our liquid form. Liquid, anything that is liquid. Okay. So gases exert the same pressure on the walls of the container in all directions. Now we will discuss atmospheric pressure. So here our atmosphere extends to several kilometers above the sea level. The weight of the air acts as pressure known as atmospheric pressure. Now, one thing you have seen that whenever those people who are going for driving or they are just going to search anything in that is at the bottom level of the sea or under the sea, they are going just for their occupation. At that time, you can see that they are wearing a jacket, right? Just to avoid the pressure, because whenever they are in a very depth, at that time the pressure is very, very high. So several kilometers down the sea, whatever the pressure, that is also very high at that, and also the atmosphere extends to several kilometers above the sea level. That means I am talking about the mountain. At that time, you can see that the atmospheric pressure is low. Okay, so the pressure in our body, we are at the surface of the earth. So the atmospheric pressure in the pressure in our body balances the atmospheric pressure. That's why you are not tilting left side or right side. We are just standing straight. So that is the main reason. But whenever the pressure falls, someone you know that they are telling I have low pressure. The doctor, he or she has checked with the blood pressure machine that uses the mercury, and sometimes they are saying that he has low pressure or high pressure. The patient has the high pressure or the low pressure. The patient has the high pressure or the low pressure. So the pressure in our body that balances the atmospheric pressure. If one person he has high pressure, at that time he has to take the medicine to be normal, right? So otherwise internal hemorrhage may be there. So the weight of the air acts as pressure known as the atmospheric pressure, and this atmospheric pressure that balances that maintain the balance of our pressure inside our body. Now, here you can see that the atmospheric pressure is the pressure that around us. Always we have so many pressures. But now the balance is there in between our internal body pressure and the atmospheric pressure. That's why we are not falling, right? But atmospheric pressure is due to the weight of the air, and the weight of the air column of the height of the atmosphere. Here you can see that this apparatus, here you can see that 10 centimeter into 10 centimeter large, here 1000 kg. So here you have the air column. Now this rubber sticker you are using whenever we have, suppose, dining table that is made up of glass. At that time we are using sometimes rubber sucker, or rubber sucker also we are using in case of our automobiles also, right? So these are the atmospheric pressure. These are the applications of the atmospheric pressure. Now, how does the atmospheric pressure change with altitude? That a little bit I have discussed. Now, elaborately I will discuss here. Now, all of us, we have seen, who are going for the tracking, they should be very much careful about the air pressure, because at the high one point is there, oxygen is less, air pressure is less, so oxygen is less. At that time, sometimes they have to carry the oxygen cylinder, as well as sometimes this practice is also very important, because if the person is at this position, here you can see that the atoms, whatever the atoms in this air, the interatomic space of these molecules, these are higher than the interatomic space, that is the air that we have at the bottom of the mountain, right? So here here you have the high pressure, you have the lower pressure. So if we have the lower pressure here, that means whenever altitude increases, at that time you can see that the pressure decreases, the atmospheric pressure decreases. So please remember one thing that is very, very important to keep in mind for the persons who are going for tracking in a very high, in the mountains. So here the atmospheric pressure that varies with the altitude as the density of the air decreases as we rise up and air becomes rarer. Sometimes you can see that whenever you are just tracking, after tracking, or you are just going upward, okay, at that time you can, upward means hilly station, you can see that some air, lack of air, this you can feel. So atmospheric pressure that decreases, with the increase in altitude. So if I am at this point, the atmospheric pressure is very less. Now if the atmospheric pressure is very less and my internal body pressure, that is also same, at that time there will be some disbalance, and this disbalance may affect my internal body parts. So I may fall sick. So at that time, so that always I am just saying, if anybody is going for tracking, at that time you should keep in your mind what will be the change in the atmospheric pressure where you are going, right? In the hilly station also, sometimes we can see that if the hill station that is very high, the height of the hill station is very high, and the height of the station, whenever it is saying 10,000 feet, 10,000 feet, that means it is with respect to the sea level, So here you can see that at this height, what will be the atmospheric pressure, that is very, very important for aged persons, also for some persons who are sick, right? So here we know that the density of air becomes heavier near the surface of the earth. Density of the air becomes heavier and begins to lighten as we are going upward, So higher altitudes, we have empty space, and outside the atmosphere of the earth. So at that time, we are saying that this has the low pressure. Thus, atmospheric pressure is high at lower altitude. At lower altitude. In this column, you just see the molecules. Here, intermolecule space is so high that here you can see that this pressure is less than this one. So, at high altitude, you can see that you have the pressure is high at lower altitude and pressure is low at higher altitude, and density being higher. Okay, the pressure is high at lower altitude and density also high, because density is what? Density means you have so many molecules here. Here you have so many molecules. No. So the density is higher at this lower altitude, but the density is very small or very low at the higher altitude. Now, this type of questions may come. That is, what is pressure? What is the SI unit of pressure? What is mean by atmospheric pressure? What is barometer? Who developed the mercury barometer? Torricelli. Obviously, in your mind, it is coming Torricelli, right? So, all these questions already we have placed. Now, application of pressure in daily life. Yes, we are using the area of the edge of the knife blade is extremely small. In the last lecture, we have discussed why this will be small. Why this will be small. So a knife's blade is extremely small because it creates high pressure, and we can use this knife's blade to cut any material. Now, another thing, the syringe. As I know, if you are going to take admission in your school, at that time the blood group, that is very important. Or sometimes if you are feeling not well, at that time also, that time also this thing is very important, that is the syringe. Okay, that means with the vaccine also, you have taken the COVID vaccine, so that is also we are using the syringe. So these syringes that are used to take the blood for the blood test, this also uses the pressure. Okay, and the pressure of the liquid, that is the blood. Here the liquid is the blood. The forces the liquid to move into the syringe when its plunger, this is the plunger. Okay, this is the plunger, is withdrawn. This is the plunger. Whenever you can see that it will be removed from here, the blood that is filled inside this one, right? So another thing, the air is sucked out of a drinking straw. Fine, this already you have seen. With the straw you are drinking your cold drinks, you are drinking your juice. So at that time you can see that if you are sucking out at that time, that means whatever the air you have inside the straw, that you are sucking out. So what happens? It cannot be back in. So due to the atmospheric pressure, the juice will come inside the straw, right? And here this child, you just see this child, what he is doing. So here you can see that the sucked out of the drinking water and the atmosphere, due to the atmospheric pressure outside, forces the liquid to go. And here you can see that skis have a large area to reduce the pressure on the snow. That's why this ensures that skis do not sink into the snow too far. Now, this is the shoe of a football player. So why this one? The pressure under, just a minute, the pressure under that starts on the sole of the football shoes is high enough and for them to sink into the ground, which gives extra grip, right? And this structure we are doing at the bottom of the shoe just to increase the pressure. Okay, so the pressure under the starts on the soles of football shoes is high. And a vacuum cleaner, already in all of you have the vacuum cleaner in your home. Just observe that thing. The vacuum cleaner has a fan inside, that creates the low pressure inside the device. So this is the vacuum cleaner. What it will do, if some vacuum will be created here due to the air pressure, this air pressure, it will just move inside. So how at that time you can see that whatever the pieces, suppose you have kept one piece of paper or whatever the pieces, they will also move inside. So that is the vacuum cleaner. That means in that case also we are using the air pressure. Here already I have discussed these two things. Starts on the soles of football shoes, increase the pressure on the ground. Here we can see that the white shoulder pads attached to a heavy, just a minute, the white shoulder straps you have, whatever the bags you are using. So sometimes it may be some pads we are using attached to heavy school bags. Now it reduces the pressure on the shoulder. That's why some here you have some shoulder pads. Here you can see that he is using a tool to dig the mud or to dig the field. Here the edge, this edge is very sharp. And here you can see that in the animal kingdom also, this elephant have broad soles to reduce the pressure exerted on the ground, because you know that elephant is very heavy animal. So if you have a pinpointed you have pinpointed pinpointed leg, at that time you can see that the pressure will be very high. So that's why the broad area that will reduce the pressure. That's why whenever it will move, you can see that there will be some step marking here, but it is not like that. The ground, there is a very depth hole in the ground, right? So polar bears have wide paws so that they do not sink too deeply into the soft snowy ground due to their heavy weight. So polar bear, they have wide paws. This is very important. Thank you.